26 centimeter mean diameter ring. Then your conductors per stator slot is equal to 14. Conductor per stator slot is equal to 14, and your resistivity is equal to 0.02 ohm per meter per millimeter square. Your resistivity is equal to 0.02 ohm per meter per millimeter square. So calculate rotor bar and end ring currents on and the rotor copper loss. So we have to calculate 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 rotor bar and end ring current, and also what, and the rotor copper loss. So first we have to go about the end ring current. So after we can see from this given data what we is available. We have read the question. So if we look again, I'll read it, 40 HP. So in the given data, if I have to write power, so you'll write power is 40 HP, and the voltage, stator voltage ES, would be 400 volts. Machine is three phase. Number of poles is equal to 6, and your slots in the rotor are 45, whereas slots in the stator are 54. Turns in the stator is equal to 126. Then okay, area also is given. Okay, the cross sectional area 11 mm into 6.4 mm. Your mean length of the bar is also given, that is 22 centimeter. Then your eddy current, that is your this thing, your sorry, what is it your current density in the end ring is also given, 6.5 ampere per millimeter square. Then again your this mean dia of the end ring is given, that is DE is equal to 26 centimeter. Then your how many one slot will hold how many conductors, that is ZSS, that is equal to 14, and rho is given. So we'll write the given data. So after you have read this question, from this particular question we can see the given data. So the given data, okay. So in the given data, the number one thing we have is, in the beginning we have the power, that is equal to 40 HP. 40 HP. Then we have the stator voltage, that is 400 volts. Apart from that, we have the machine is three phase. The number of poles is equal to 6. Okay, and the stator, this is the stator slots in the rotor. Let this be SR. 45 SS is equal to 54. Slots in the stator is equal to 54. Turns in the stator is equal to 126. 126, and your area, rotor area, or the bar current area, that is area of the bar, is 11 mm into 6.4 mm. Then you have length of the bar, that is 22 centimeter. Then you have the eddy current density, that is your current density of the end ring, delta E, that is 6.5 ampere per millimeter square. Then you have your mean dia, that is your mean dia of end ring, that is DE. Mean dia of the end ring I have written as DE, that is equal to 26 centimeter. Then you have the slots, this is 14, and then you have your resistivity finally, that is 0.02, 0.021. It is 0.021. So what is that? And your I square R. So these are the things rotor copper loss you need. Mention of efficiency and power factor. Okay, when there is no mention of efficiency and power factor, so what we can do is that in the normal case scenario, our power factor and induction motor efficiency is around zero point 0.9. So let's assume the efficiency and power factor to be zero point 0.9. So first step would be uh, to assume efficiency and power factor is equal to zero point 0.9. Okay, then your input kVA you have in the very beginning. I have wrote this formula. Input kVA is equal to your 0.746 into HP divided by efficiency into cos phi. So this we have 0.9. Okay, so the input kVA HP value we know, so we can substitute here. HP is how much? This is 40 HP. So substitute the value of 40 HP and here zero point 0.9 and zero point 0.9. So you will get this as 36.89. Okay, this you will get around 36.89. So this is 36.89 after you substitute the values of 36.89 kilowatts. Okay, so and usually what happens is here there is no mention of any connection. This is a very typical question, that's why I have taken this. So now the voltage level is giving you 440 volts. Now you tell me one thing. Usually what happens to the stator is we always connect it in delta fashion. So the stator is given delta fashion, not the star fashion. So why it is done? Why the induction motor is started with delta? With delta, what happens is that the voltage in the phase and the line remains same. So initially the torque you'll get comparatively more, but in case of the star connection, the line the phase voltage will not remain same. So let's assume the delta connected stator and stator voltage per phase is 440 volts and stator current per phase. See, now the stator voltage is given, ES is given 440 volts. Now this current we require IS. So the current IS would be input kVA into 10 power 3. So this is what input kVA, input kVA into 10 was the three phase current 3 into ES. Basically what we did is kVA is what? kVA is 3 VI into 10 power 3. So we needed this IS, 3 VS IS, or sorry, 3 ES IS. So we need this IS, that's why I substituted here. So again, if I see input kVA, I have calculated. Okay, so the input kVA is 36.84. Okay, into into 36.84 into 10 power 3 divided by 3 into 440. So this would be input kVA is 36.84 into 10 power 3 divided by 3 into ES 440. So here you tell me the value how much you are getting. 36.84 into 10 power 3 divided by 3 into 440. Yeah, tell me Ratika. Calculate please. Calculate. Calculate. How much you are getting? Yeah, Manohar.
Yes, sir. 27.91, sir.
27.91. So everyone has to do na 27.91. So you are getting 27.91. So once you got this value, now you need to calculate the uh, 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 see the rotor mmf is 85% of the stator mmf. So you know the rotor bar current would be here in the background. If you see 85% stator mmf. So I can write down the rotor bar current in the yesterday's class what we had done. So do like that only. Put that IB would be equal to how much? Tell me. Would be equal to 0.85 into 0.85 into IS TS divided by IS TS divided by SR. So tell me the value. So please can you tell me the value? Tell me, substitute the value of IS value also you have 27.91. TS value you know it is 120. Stator the slot value also you know is 44. So tell me the value. So here you can substitute now. This is 0.85. IS you calculated 27.91. This TS value is given there 126. Then these slots are 45. So tell me this IB, how much you'll get? Yeah, tell me.
66.43.
Yeah.
66.43.
No, 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 no. 0.36.43 here. So how much you getting? Sir. Yeah, how much is the value? Hmm? 60? Okay, now the rotor entering current. So if you have to calculate the rotor entering current, IE, so the rotor entering current, IE, if you want to calculate it, is as simple as that. That is SR IB, this formula I derived yesterday, into pi P. So the SR value you know is 45 into IB value, how much you calculated? Tell me. IB value, how much you calculated?
66.42.
Pi 66.43. 43. Multiply this with 6. How much you are getting? Why he has multiplied this with yeah. Multiply this with 6. Hmm? This you multiply with 6. How much you are getting? Yeah, multiply this with 6 and tell me. Wait 1 second. I'll just do and this value also you tell me. Okay. So how much you are getting IE value?
IE is 155, sir.
155. So yesterday when we derived the expression for the bar current and the entering current, okay. So the bar current was equal to this value, and the entering current that I designed was equal to this value. But in this particular problem, did we miss something? Hmm? I think if you go to the yesterday's class, okay, so if you are going for the bar current, okay, was bar current only 0.85% of this, or there were some other factors involved? Hmm?
It was 0.85 into 6, sir.
Hmm? 6. So why you did not take that 6? Because that ms, the number of phases you have to take into account. 0.85 into the number of phases and IB into rho by 2. So it has to be 0.85 into 6. So that's what I wanted you. You people are not alert. That's why I deliberately wrote it wrong. So it has to be 0.85 into 6. So this term you have to multiply with 6. So how much you will get? If you please check the yesterday's class also, so you'll understand. It was point 0.8. It was not 0.85 ISTS, but it was 0.85 ISTS into 6. That we also derived. Okay, because your rotor mmf is equal to your rotor mmf was equal to your bar current into your number of rotor turns, and the number of rotor turns were SR by 2. So it was IB into SR by 2 is equal to MS ISTS, and MS was 3 number of phases. So this 2 IB into SR by 2, the 2 value would go there, multiply with the number of phases, and it will become 6. So it has to be 6. Okay. Now you recalculate and tell me, please. Hmm? You have to interrupt because this is a normal classroom going on. So you know,
398.55.
yeah,
IB 98.55.
so 398.55. Okay, 398 you can assume it as 398 also. But what about the IE? So the IE value
951.46.
951.46. Now can you yourself do the rotor copper loss? How much it will come? Try for it. How much you have to do? You can take this as see. You can take this as around if you can approximate to the nearest integer value, so it would be 398 amps. Okay, putting nearest integer not 398.5, that is okay. I have just approximated to the nearest integer. Each entering is given. AC is equal to now uh, cross sectional area in terms of the current density. You can write AC is equal to entering current divided by your current density. Entering current is given. Okay, this value is been given. This value is around 6.5. So you can get 1 millimeter square. So this value will get in. Then you go for the total copper loss. Now, total copper loss in the rotor, it would depend upon what? If you take bar current into account. So in the bar current, so see, suppose you have R is equal to rho L by A, but the rho L by A, you have to take all the conductors into account. So to take all the conductors into account, you have to take the rotor slots into account, because if there are 20 slots, so every slot having so many conductors, okay. But here it's mentioning the number of rotor slots SR is equal to 45. It's not mentioning whether one conductor is having 20 slots or 30 slots, not like that. So directly what you do is that first of all you write, in order to go for that, total copper I square R loss, you have to write SR, okay, then IB square, that is I square, then R. For R, what you have to write? R is equal to rho L by A. Okay, R is equal to resistivity into length into area. So resistance you can write rho value they have mentioned, length also mentioned, area of the this thing also 11 into 6.4 millimeter it's mentioned, rho it's mentioned 0.021. Okay, length of the mean path is given 22 centimeter, that you have to convert. So that thing you have to write in terms of millimeter. Okay, so LB is given, your LB value is given as 22, AB is 11 millimeter into 6.4 millimeter, LB is equal to 22 centimeter. So all these values you have to put there. So here you can safely write your this value in terms of uh, so you have 0.021 into 0.22 divided by 11 into 6.4, okay, into SR value is 45, IB value is 398. Now this is not only the loss happening in the bar, you have to calculate the total copper loss. So the other loss that would be happening is where that would be happened in the end ring. So end ring you have on top and on bottom. So for end ring the loss would be twice. So 2 times IE square, and same thing rho L by A. Rho L by A. So the length of the end ring, or the area of the end ring you calculated. But what about the end ring length? So end ring length you can calculate by the circumference of it. That is 2 pi r or pi d. So pi value is given, DE value is given 0.26. Okay. So DE value is what, it's already mentioned there. The DE value is 26 centimeter. Okay. So this centimeter you establish because the all the other values 0.021 ohm per meter per millimeter square. So first of all you have to establish this in terms of, see here, what all the terms are there in millimeter. For example, that 0.021 is the standard unit, so you have to establish all the other quantities. So in terms of that, because that is in terms of that quantity. Okay, so per meter per millimeter square, so per meter means 22 centimeter, you have to divide by 100, so it would be 0.22. Again, that 26 centimeter you have to divide by 100, so it would be 0.26. So the total copper loss, how you will write is, I have not written because I am giving you the idea. So how you will write, now you have to calculate the total copper loss. So calculate the total copper loss. So in order to calculate the total copper loss, so you'll write down total copper loss would be equal to your number one is your bar current. In the bar you have SR, this is the total number of rotor slots, because these slots will only account, now you are not taking for only one slot. In one slot if it is, then it would be into one, this would be IB square into R. So instead of R we'll write rho, okay, rho LB AB. So this accounts for the bar, so this is the bar, plus you have in end ring, you have end ring, see, you have an end ring on top, end ring on bottom. So the loss there would be, see, this is the bar, so one loss here, one loss here, so twice. Okay, twice again IE square. Okay, again you have to row L by A. So rho L by A. So end ring, what you have, what is the L here? End ring. End ring you have to see because it's circular cross section. For example, if a circle is there, what is the length of that? Sir, it is 2 pi r or pi d. Same thing you have to take pi d divided by your area of the end ring. So area of the end ring you just now calculated. Now you substitute the value. The value SR would be equal to 45. IB value you just calculated was 398. Okay. Square row value is given 0.021. This LB value is given 22 centimeter converted to meter. So it would be 0.22. Okay. AB value again is given. AB value is given. See, AB value is given 11 into 6.4 is given again plus this twice. IE square is given 950 whole square. Okay. Then you have into 0.021 into pi into 0.26 divided by your again your 140 IE value you just now calculated 146.15. If you simplify this expression, so you will get around 679.6 watts. So this is 679.6 watts. Any doubt you are having anywhere, please tell me. This is how you do this particular problem. So let me give you one more problem and let's see how you'll do. Okay. So very simple I'll give. Okay. So that you will be able to do. So this you have to do. Ratika, are you having any doubt? Ratika,
No, sir. No,
Diksha,
sir.
Diksha. So I'm giving you this problem. Okay. Please try to do it. Okay. I'll please try to solve this problem. Very simple problem. It's not a big problem, so that I'll get this thing confidence that you have understood. Okay, a six pole, uh, three phase squirrel cage induction motor has 72 has 72 slots has 72 slots with 12 conductors 12 conductors per slot 12 conductors per slot in it in it uh, in it there are 55 rotor slots there are there are 55 rotor slots. So this is about the stator slot, 72 stator slots. Okay, 12 conductors in it. uh, there are this thing. Okay, after that determine the current in the rotor bars and in the end ring if the stator current across the face is 30 ampere. So you have to, it's a very simple, determine determine the end ring current and what, and bar current, that is rotor bar current. So if the what, if the is, that is your stator current, is 30 amps. So I will write down given data. It's given. So what is given is that number of poles is equal to 6. Okay, and number of poles is equal to 6. This is the given data. And what else is given? Your stator slots 72, your rotor slots 55, your ZSS value is equal to 12. Okay, your IS is equal to 30. Now you have to calculate IB and I. Please calculate these values and let me. Please calculate. See, IB you have to substitute directly. You can substitute. Yeah. Please calculate these values. Please do it. See, for what you will do, assuming motor MMF is 85% of stator MMF, so that IB formula you know 0.85 into 6 into IS into TS divided by your this T. So now you have to calculate the turns per phase. So in order to calculate the turns per phase, how do you go about the turns per phase? So turns per phase would depend upon what? See, I have time and again I have told you turns per phase. If you do see in the rotor, how many in the stator, how many slots you are having? 72 slots with 12 conductors per slot. So total number of turns would be equal to what? Total number of conductors would be equal to what? Total number of conductors would be equal to 72 into 12. That is total number of conductors. 72 into 12. Okay, that is so. Now turns, in order to get the turns, 72 into 12. So turns would be 72 into 12 divided by 6. Okay, 72 into 12 divided by 6. So you got the turns. So how much that would be? That would be 72 into 2. So the number of turns you got 144. Are you able to follow or not? Ratika? Hmm?
Yes.
Noor. Noor. Then why you are not doing? Do the problem. See, the thing is that this was for you only. That live I wanted to hear. See what happens is when you are doing this problem. So only thing is that IB is equal to 0.85 into 6 into IS into TS divided by SS. Available. So in order to get to TS, how do we go? So this is 12 conductors, this is 72 slots. So total number of conductors Z would be equal to, that is Z would be equal to 72 into 12. Okay. So this is the total number of and into 12 by 6. That is TS would be equal to Z by 6 for three phase. If it was a single phase, then Z by 2 for single phase. This TS. So here I calculate 6 ones are 2s are. So this is nothing but I got the value of TS also 144. So I can write 0.85 into 6 into IS value is 30 into 144 divided by 55 and get an answer. So what is the big deal in that? Please do na, please you have to do. In the examination also you have to do yourself. See, it's not a point that I time and again I'll be solving the problem. So how much value you will get? Around
400.
400,
Yes, sir.
400.5 to 5,
5
511, 5,
5 8.
576. Okay, 400.58. So this is 400.58. Calculate the IE value. IE value is what? Just now we saw. What was the IE value? Tell me. Was
Yes,
IB
sir. IP by
divided by
pi
pi
p.
pi p. So see, so these values we have. So this is SR. Okay. So SR. This is SR IB by pi p. So these SR value is given. So see here only we will write. So this is given IE value if we have to calculate SR IB by pi p. So SR value is given. How much is the SR value? For the these are
55.
the for 55 rotor slot. So write down that 55 you have to write and calculate this value and let me know. Yeah. So 55
168.82.
into 400.88 or divided by pi into 6. So this would be around 1168.82.
68.82.
Yeah,
82.
1168.82. Okay. 1168.82. Okay. This you are getting?
Yes, sir.
Yeah? Yes, you are getting this answer? Question and you should be doing within fraction of seconds. Should not take time for doing this. Okay. Now one more question I'll give. I want you people to do. Please do it. Huh? Please don't waste time like sir will only do, sir will only do. Then what is the? This is so simple. This is not like neither there is some heavy mathematics involved like integral calculus or something like that. It's simple, na? Okay, do this question. I'll enlarge this so that you can see the question. This is the question third. 120 HP, 400 volt, 120 HP, 400 volt, 50 hertz, three phase, three phase, 8 pole induction motor has a stator connected has a stator has a has a star connected stator winding has a wait it is has a star connected, this is star connected stator winding, this so it's star connected stator winding already it is mentioning. So accommodating slots with six conductors, so it will I'll write star connected stator winding with accommodating six conductors per slot. This is accommodating six conductors per slot. Okay. Wait. Uh, and if the slip ring voltage on open circuit is to be 320 volts, that means what it is stator voltage is 320 volts. If the slip ring voltage on open circuit is 320 volts. 320 volts. Find the following for rotor of the motor. Find the following for find. I'll write find the following. Okay, find the following because we find the following. Number one is number of slots. That is number of. This is we have to follow for the number of rotor. So this is number of rotor slots. Okay. Number two, what you have to find out is number of conductors per slot. Number of conductors per slot Number three that you have to follow is number of conductors per slot. Okay. Number three is rotor current per phase. So rotor current per phase, and see, you have to assuming rotor MMF, assume rotor MMF is equal to 0.85 stator, 0.85 times stator MMF, and efficiency is equal to zero point 0.9. Efficiency is zero point 0.9 given, and power factor is equal to 0.85. So given, if it is not given, you take both as zero point 0.9, zero point 0.9. So how do you do about go about this problem? So first of all, what is the given data from this question? So we have the given data. So the data that has been given, first of all, what is the number one thing? The power is given of the motor is 120 HP. Okay. Second thing that is given in this case is your stator voltage, open circuit voltage, 400 volts, and this is star connected. So mind it. So you have to divide it by root 3. It is not delta connected. Okay. So that you have to mind there. Your frequency is 50 hertz. Okay. Three phase, and your number of poles is equal to 8. Number of poles is equal to 8, and your stator slots is given SS, that is 60. Okay. And connected winding 400 volt 3 phase 8 pole has a star connected stator winding with a commutator 6 conductor per slot. So your 60 actually has connected stator winding with 60 slots. I just forgot 60 slots over here. So this is given 60 slots, and your ZSS is given, that is equal to 6, is equal to 6. And another value you have is your ES value. Sorry, ES value is this thing. Your ER value is given, that is your rotor side volt open circuit voltage, that is given, that is 320 volts. Okay. And you have your, now you can write your IR into TR. See, you can write IR into TR, that is the MMF on the rotor size is 0.85 times IS into TS. So this is given, and your efficiency is zero point 0.9, and your power factor is 0.85. So how do you go about this problem? See, so what you have to find is you have to find SR. Okay, the value. So what you have to find is you have to find SR value. Another thing what you have to find is the conductors per slot, that is SR. Like here it was 6, there you have to find that value. You have to find the value of IR, rotor current. Okay, then you have to find the value of, okay, these are the things that you have to find. Now how do you go about this problem is, see, and the number one thing is that the number of stator conductors, total number of stator conductors would be equal to ZSS into SS. That would be ZSS is 6, 6 into SS would be 60. So the total number of conductors is 360. So if the total number of conductors is 360, because it's a three-phase machine, so the number of stator turns per phase TS would be equal to ZS by 6. So that is 360 divided by 6 would be 60. So now you got the value of TS. Now stator voltage per phase ES is, because now it is star connected, so it has to be 400 divided by root 3. So it would come around 231 volt. So 320 you need to divide by root 3, so it will come around 184.75. Now, one more thing is that you have to assume the winding factor, that is distribution factor, into the pitch factor to be 0.90, because I have told you this you have to assume whenever it's not given. Now from this you can write down the number of rotor turns per phase, that TR value. So we know that your TR by TS, okay, TR by TS is equal to ER by ES is equal to KWS by KWR. So you can write TR is equal to KWS by KWR into ER by S into TS. So KWS by KWR will get cancelled, okay, because they will be almost equal. So this would be 1 into the other values and TS value. So you get the value of TR, okay, from that. So similarly, once you get the value of TR, so number of rotor conductors ZR would be 6 times TR. So it would be 6 into the TR times. So once you get this value, so the number of stator slots that you needed would be SR would be equal to 3 PQR. So assuming your rotor slots per pole per phase QR is equal to 3. So that would be SR is equal to 3 times number of poles is 8 and QR value is 3, that would be 72. So number of rotor commutator per phase, so like this you have to do, okay. So I'm giving you an brief idea. So how do I go about this problem? So you, the problem is in front of you. So I'll just show you that what you have to do is that in this particular problem is that you have number of, so you have SS into ZSS. So SS value is given. So let's do it here only, okay. So let's calculate here ZS. So let's calculate here ZS. So ZS would be equal to SS into, tell me, ZSS. So this is the total number of conductors. Basically, this is total number of conductors, TC, let me write. And this is the slots. So total number of slots, 60 slots, and every slot containing 6 conductors. So this is equal to 360. So this is a three-phase machine. So TS would be equal to ZS by 6. ZS by 6. This would be nothing but 360 by 6. So total number of turns would be 60. So once we get the value of TS, okay, then what we have to do? Tell me. Once we get the value of TS, then we have to calculate the value of what? See, from once we got the value of TS, now you have the stator voltage. That is your ES. Sorry, stator voltage ES. Though so the stator voltage ES would be equal to basically 440 divided by root 3 because it is star connected, and ER would be equal to 3 320 divided by root 3 because it's star connected. Star connected. That's the reason. This 440 divided by root 3, you will get around 231 volts, and similarly this you will get around 184.75 volts. So once you got these voltages, so you can write TR by TS is equal to what? ER by ES, or into, if you have the winding factor also, KWS by KWR. So this is not, if you need this will become 1, no problem. You can directly also write TR would become ER by ES. So ER by ES you have to write 184.75 divided by 231 volt into TS you have calculated 60. So when you approximate, so this will come around 48. So this comes around 48 volt. Now you got the value of TR, okay, TR. So ZR would be 6 times TR, okay, similar concept, 6 into 48. So 6 into 48 you get around 288. So 288. This is the total number of conductors are there. How many rotor turns are there? like ZRR value you require to establish the number of slots per conductor. Okay, so that is also required there. So ZRR value you can get by ZR divided by SR. So this value you have to calculate. So in order to get this ZRR value, first you need the value of SR. So the total number of slots, if you want to calculate, is the number of rotor slots for a three-phase induction motor. Already I have told you the of rotor EQR, because it's for the phase. P is the pole. See, you can write assuming rotor. This is the slots per pole per phase. So this is like slots you have to establish the number of phase is given. It is also fixed. So only thing is that PQ in the PQR, see, this value you can change. Okay, number of poles and phase are given. This is the number of poles and into number of poles 8, number of phase 3. So it's a three phase machine. So that's why. So you get it around 72. You get it around 72 for this equation. So again, if you want to the coil span also, you can aram se get the coil span. The coil span would be the number of conductors, the total number of conductors, that is your, sorry, the slots, that is 72 divided by P, that is 8. 72 by 8 is equal to 9. So by this method you can get the coil span. So as far the number of slots are concerned, so you get it around 3 PQR. So this is, sorry, uh, yeah, here this is 3 PQQR means this value. Okay, so this is the number of poles. Okay, and this is the number of phases. Okay, so basically, and the number of, for a three phase machine we write is 3 PQR. So now you get this value as 72. 3 into 8, 24 is a coil span. If you want coil span, that would be 72 divided by 8. So it would be 9. Now if you want the this slots, that is the ZSS value. So this would be ZS by SS. So ZS 288 divided by SS 72. You just now saw that. So how much value you will get? Tell me. So this you will get 72 by 288 would be roughly equal to, it would be equal to 4. The current, so current you can, yeah, any doubts? Please tell me. Yeah. So yeah, time is up. So I'll just wind it up. IB value you need to calculate. So it would be input kVA into 10 power 3. You please give the, start giving the attendance. Okay. So this is the rotor current you have to calculate. Taking it down. In the next class, we'll start with this only. So by now you can this, you please give your attendance. I hope